All right, so I'm gonna sketch number 15. All right, so first thing I'm gonna do is I'm gonna find information about it just looking at the original function. So first thing I'm gonna look for is my x-intercepts. So to find my x-intercepts, I set y equal to 0. When I set y equal to 0, I put 0 over 1, I cross multiply, I get 0 equals x squared plus 1. All right, now when I solve this, I move over 1. I get negative 1 equals x squared. I take the square root, and when I take the square root of a negative, I have an imaginary answer. So because I get an imaginary answer, that means that there are no real x-intercepts. All right, now let's do y. Y-intercepts, you set x equal to 0. So we get 1 over 0. This is undefined. So that means that there are no y-intercepts. All right, moving on to our asymptotes. Our vertical asymptote is found by setting the denominator equal to 0. So my first thing I have to plot here is my vertical asymptote, which is x equals 0. So that's directly on the y-axis. So I'm just darkening it in to show that that is my vertical asymptote. All right, next. I can find, all these puzzle pieces, my horizontal asymptote, which is looking at the degree. So the degree on the top is bigger than the bottom, which means that there is no horizontal asymptote. All right, now in the last video, I accidentally wrote vertical. When you are looking for your slant, it's when the degree on top is 1 bigger than the bottom. We use synthetic division. All right, so the x squared term has a coefficient of 1. There's no x term, so don't forget the 0. And then the constant term. What goes on the outside is not the factor. What goes on the outside is the 0. So the bottom 0 is 0. Pull down the 1. 1 times 0 is 0. Add. 0 times 0 is 0. Add. Oops. Okay, so this is my remainder. This is my constant. This is my x term. So my slant asymptote is y equals x plus 0. Or just y equals x. All right, so now I'm going to go to my graph, and I'm going to graph that. So I start at 0, and I go up 1 over 1, because that's the slope of the line y equals x. That's my slant asymptote. All right, now I'm going to find the derivative. So I'm going to rewrite the function. Okay, the derivative of the top is 2x. The derivative of the bottom is 1. So now we do bottom times the derivative of the top. So x times 2x minus 1 times x squared plus 1. This times this minus this times this. So we have 2x squared minus x squared. And I'm pulling that minus 1. So I have x squared minus 1 over the bottom squared. So the bottom was x. So the bottom squared is x squared. All right, so now I'm going to find my critical values. So I'm going to set the first derivative equal to 0. I'll put this over 1 and cross multiply. I have 0 equals x squared minus 1. So when I solve this, I get x squared equals positive 1. Add the 1. Take the square root, and you get two critical values, plus and minus 1. All right, so now I'm going to break up my number line using some of these critical values. So first thing to break up my number line is my undefined, 0. That was my vertical asymptote. And then the critical values of 1 and negative 1. All right, so we have negative infinity to negative 1, negative 1 to 0, 0 to 1, and then 1 to infinity. All right, I need my first derivative to test it, so I'm going to pull my first derivative over, which is x squared minus 1 over x squared. All right, let's check the first interval. So the first interval, I'll put in negative 10 into my first derivative. So this is 100 minus 1 is positive over positive, so the whole thing is positive, which means this piece of the function is increasing. All right, now I have to use a fractional value. So I'll use negative 1/2. All right, so negative 1/2 squared is 1/4 minus 1. That's negative. Over a positive, because negative 1/2 squared is 1/4. So negative over positive is negative, which means the whole thing is negative, which means we're decreasing. All right, so remember, this was a critical value here. So because I went from increasing to decreasing, I know that I have a relative max here. All right, next. Remember, 0 was my undefined value, so I'm not going to have a relative minimum or maximum there, but I do want to know the behavior of the graph. So 1/2 squared minus 1 over 1/2 squared. So we have 1/4 minus 1, so that's negative over positive, which means the whole thing is negative, which means my graph is decreasing. All right, now here was a critical value, so I have a potential to have a maximum or a minimum here. So 2 squared minus 1 over 2 squared. So 4 minus 1 is 3 over a positive number. So we have positive over positive, which makes it positive, which means I'm increasing. So I'm going from decreasing to increasing, which means I have a relative minimum. Okay, so since I have a relative maximum at negative 1 and a relative minimum at 1, I need to actually find what points to plot. So I need to go back into the original function. So the original function is f of x is equal to x squared plus 1 over x. So I'm going to plug in negative 1. So when I plug in negative 1, I get 1 plus 1 is 2 over negative 1. So that means that my relative maximum is negative 1 comma negative 2. All right, now I have to find my relative minimum. So same deal, I'm putting it into the original function to find the point on the function. I'm putting in 1. So I have 1 squared plus 1 is 2 over 1, which is 2. So my relative minimum is 1, 2. All right, so let's plot these things. All right, so negative 1, negative 2 is right over here. And 1, 2 is over here. All right, so now from negative infinity up to 1, I'm increasing. And then from -1 to 0, I'm decreasing. So I'm increasing up to that point. Remember, I'm stuck in between the asymptotes, so I can't move. And then I'm decreasing. Okay, then from 0 to 1, I'm decreasing, and then I'm increasing. So decreasing, increasing. And that's my picture of f of x.